we know that speed or velocity is equals to distance by time. Now we can write this change of distance as a small d or delta. So dx by dt. That's a mathematical notation for writing distance by time. And we can write v for velocity. And similarly we can write acceleration equals to change of velocity divided by time. That means change of velocity is dv and change of time is dt. So that is dv by dt and acceleration is a. So velocity is dx by dt, acceleration is dv by dt. Now we can do this using algebra. Suppose we have an expression for distance in terms of time. So suppose distance is t and we want to know how far something moves just a little bit. Let me call it h. So if you start at the starting point, then x equals to t. If you move on to another point, x equals to t plus h. So we are moving from t to t plus h, just a little time. So if you take this time, you find an expression for distance. If you put this time, you get another expression for distance. So the velocity is going to be change of distance. So the change of distance is going to be t plus h minus t, and the change of time is going to be t plus h minus t. Here both the expression for distance and time is the same. If I cancel this out, this is h and this is also h, and h cancels out as to 1. So when you have uh, distance expressed in terms of time, the velocity is going to be 1. Okay, how about if I express the distance in terms of t square? So when we start with t, then the first point is going to be x equals to t square. When we put t plus h, the next point is going to be t plus h whole square, which can be broken down using algebra, and we can write x equals to t square plus 2th plus h square. So let's find the velocity. So the velocity is going to be change of distance by change of time. So here this is the final distance, so we can write t square plus 2th plus h square minus, initially it was at here, so t square. Remember, displacement is expressed in terms of t. Now the change in time is going to be t plus h minus t. So upstairs we get t square minus t square cancels out, so we get 2th plus h square, and this t and t cancels out, we get h. And this can be simplified by dividing with h. We get 2t plus h. Now I mentioned that t is a very small amount of value. So from moving from time t to time t plus h, meaning the time change is extremely low. So we can say that when displacement is t square, the velocity is 2t. We can just ignore this h. So similarly, we can come at a general rule by observing this. When the displacement is t, the velocity is 1. When the displacement is t square, the velocity is 2t. When the displacement is t cubed, the velocity is, when the displacement is t to the power 4, the velocity is 4t to the power 3. So what is happening? So when the displacement is t to the power n, the velocity is n t to the power n minus 1. All of this is done by using algebra. So from here, we can find a change. It doesn't matter what change you're finding, you can just remember velocity is dx by dt, change of distance by change of time. Now we don't have to go through all this, lengthy algebra. We can just memorize it and use this trick. So the trick is, if you have a distance t to the power 10, you don't have to go through t plus h to the power 10 minus t to the power 10 divided by t plus h for just a small distance. You don't have to go through this. You just have seen what it looks like, and just remember dx by dt, which is the same as velocity, change of distance by change of time. This change is going to be 10. You bring this number in front and write t to the power 9. And the same thing could be done if you know velocity, suppose t to the power 5, then you can find acceleration, which is change of velocity with change of time, which is the same as bring the number 5 here and number 4 here. That's it, 5t to the power 4. So you can find the change. If you know displacement, you can find velocity. If you know velocity, you can find acceleration. Now this cool trick was the invention of differential calculus, where we can find change. It's one of the most important inventions. It is part of calculus, differential calculus. So differential calculus helps us to find change. It started with kinematics of the study of motion, where we find the change of distance with change of time, change of velocity with change of time, and on and on. So here we can change the alphabet and we can find anything.